So next method which we are going to do, that is your big M method, or sometimes it is called as your penalty method. The limitation for your simplex was that कि अगर आपकी सारी इनइक्वालिटी लेस हो देन आई कैन ओनली अप्लाई योर सिंप्लेक्स मेथड. दैट मीन्स मुझे हर वेरिएबल में, हर कंस्ट्रेंट में क्या ऐड करना पड़ रहा था, दैट इज योर स्लैक वेरिएबल. ओनली देन यू कैन अप्लाई योर simplex method, right? So big M method we use when we have equality that is greater than equal to, or it is greater, or it can be less. If it is any of the inequality, we can use big M method. Is it clear? I will just write few steps because you don't understand when I start the example, right? Then the iteration remains simple. So obviously when you convert, the first step that you have to convert your LPP into standard form. Convert LPP into its standard form. Once you have converted it into the standard form, the next is, because there can be greater than inequality and there can be equal to equality. Whenever we start simplex method, we say we start from that variables which make your identity matrix. So because surplus variable will not make identity matrix, और जहां पे आपका equality constraint भी होगा, there you will not have any slack or surplus. So what you have to do, add artificial variable. This is the one step addition to the previous. Add artificial variable where constraints has sign. Constraints have sign greater than or it is equal to, right? So when it is less than equal to, obviously there is no need to add your artificial variable. क्यों? क्योंकि वो आपकी already identity का वो column बना ही रहा होगा. That is 100. It is not present in any other constraint, right? So that you have to add artificial variable. The name you can give as per your choice. Sometimes they give R1, R2, A1, A2, and it is your choice, right? So when you add your artificial variable, the next step is, if your problem is of maximization, then add minus M into your artificial variable as the cost of your artificial variable. That is minus M into artificial variables. जितने भी आपके artificial variables add होंगे, you will do cost of in the objective function. Why you are adding and why as its name indicate penalty? Because when you are adding your artificial variable, you are adding it as per your convenience. It is not required. बिकॉज अगर आपकी लेस देन इनइक्वालिटी, आप ऑलरेडी स्लैक वेरिएबल ऐड कर चुके हो जो उसको इक्वल बना रहा है. व्हेन इट इज ग्रेटर देन इनइक्वालिटी, यू हैव ऑलरेडी एडेड सरप्लस वेरिएबल जो उसको इक्वल बना रहा है. बट आप अपने कन्वीनियंस के लिए आर्टिफिशियल वेरिएबल ऐड कर रहे हो. सो इफ यू आर एडिंग इट फॉर योर कन्वीनियंस, यू हैव टू पे द पेनल्टी, राइट? दैट पेनल्टी इज नथिंग दैट यू आर कॉलिंग इट एज योर एम, एंड एम इज वेरी लार्ज नंबर की जो आप पे कर रहे हो, राइट? And the same, if you have the case of minimization, then add plus M into artificial variables in the objective function. Rest the steps are as it is in simplex. That most negative enter for maximization, then you decide your leaving variable. That steps are remain same. That you make pivot element 1, other element as 0. So all the steps remain same as in simplex method. So we are starting with an example, right? So if you have, suppose example that it is maximize z is equal to 3x1 minus x2, subject to you have constraint 2x1 plus x2 less than equal to 2, x1 plus 3x2 greater than equal to 3, x2 less than equal to 4, x1 and x2 are greater than equal to 0. So when you will convert this LPP, and obviously if it is not given to you, right, here you are two variables, you can still use your graphical method, but you cannot use simplex method because here the inequality is your greater than equality, right? So you need not have to, you have to add your surplus variable. So when you will convert it into your standard form, so subject to, this will be 2x1 plus x2. I am adding slack variable in first constraint, so I am giving name s1. x1 plus 3x2 minus s2, that is equal to 3. x2 plus s3, that is equal to 4. And x1, x2, s1, s2, s3 all are greater than equal to 0. Because when we write its A matrix, so what will be my A matrix? This is 2, 1, 1, 3, 1, 0, 0, and this is your 0, minus 1, 0, 0, 0, 1, right? And now this is the column of x1, x2, x3, s1, s2 and s3. So only this s2 is creating a problem, that it is not making your identity matrix. You cannot multiply with minus, because if you will multiply with minus, your right hand side will become negative. So that operation you cannot do कि आप अगर आपने surplus slack variable add करना है, so you cannot multiply with the negative sign. So what is your big M method? That means you will add your artificial variable in this constraint, because I am adding it in the second constraint, so I am giving the name A2, right? So that I can remember that where I have added my artificial variable, right? So if you write the column of A2, what will be the column of A2? 0, 1 and 0. So that means now you can start your iteration. That is your simplex iteration. So how I write the columns, that this is my x1, x2, s1, s2, s3 and my artificial variable a2, and this is my xp. Some of the books here write solution, that does not affect. So this is my zj minus cj, right? And here I can write my variables, that is my, in the first, who is making the identity matrix? If you notice that this is S1, this is A2 and S3. So what will be the level? So in the first, I will have S1, A2 and S3. So since you have added your artificial variable, obviously here the cost coefficient of your slack and surplus variable will be 0, 0, 0, right? And because it is of maximization case and you are adding your artificial variable, then you have to do minus m into A2. Is it clear? Yes or no? So if you have added more variables, आप उतने ही variables subtract करते जाओगे, minus A2, A3 and so on, right? If you add more than one artificial variables, right? So because you are adding this, here you write your CB. S1 cost coefficient is 0, A2 cost coefficient is minus m, S3 cost coefficient is 0. First table आप कैसे लिखते थे? That you write the columns of A as it is. So what was the columns? That here it will be 2, 1, 0 and it is 1, 3, 1. This is 1, 0, 0, 0, minus 1, 0, 0, 0, 1 and this is the column 0, 1, 0. Here you write your right hand side 2, 3, 4. And when you write your Zj minus Cj, how do you write? Negate the sign of objective function you write. I am not writing it here. I am writing it here. I'll tell you why. I am negating the sign. This is minus 3. This is 1. This is 0, 0, 0. Minus m. If I'll negate the sign, it is my m. And here entry will be my 0. Now, the tips and tricks I have already told you. Whenever you have basic variables here, you will have identity matrix corresponding to that. It is true. And whenever your Zj minus Cj corresponding to your basic variable Zj minus Cj should be 0. क्या ये 0 है? S2, S1 के लिए तो satisfy हो रहा है that it is 0. S3 के लिए भी ये satisfy हो रहा है 0. But corresponding to your A2, Zj minus Cj is not equal to 0. So these entries, either you can calculate by the formula that I have told you, Zj minus Cj is nothing but Cb into alpha j minus Cj. So if I want to calculate Z1 minus C1, what is the cost coefficient of basic variable? Cost coefficient आपका क्या है basic variable का? 0 minus m and 0 alpha j मतलब पहली entry that is 210 minus Cj means cost coefficient x1 का कितना है? 3. So when you will multiply, actual you are writing. Here I have not written this just because to show you that you have negate the sign. When you will multiply, this will be your minus m minus 3. Is it clear? Yes. So I can write here minus m minus 3. Is the operation clear? I have used the formula. Or if you don't want to use the formula, you can use your row operation. रो ऑपरेशन में आप करते थे ना, 0 बनाना पाइवट एलिमेंट की हेल्प से. तो 1 एलिमेंट यहाँ पे ऑलरेडी है, मैंने इसको 0 बनाना है. दिस इज 1 ऑलरेडी हेयर, क्योंकि A2 के लिए ही मुझे इसको 0 बनाना है, राइट? सो यू कैन यूज द ऑपरेशन आर नॉट. दैट आर नॉट विल बी योर आर नॉट माइनस m टाइम्स योर R2. इज इट क्लियर? ठीक है. If you have confusion with m, solving the problem you can take m as very large value, 1000, 10,000, जितनी भी आप लार्ज, जैसे अब यहाँ तो आपके 1 और 2 में ही वेरिएबल्स हैं. You can take m value as 100 अगर आपको कैलकुलेशंस आसान करनी है, right? So when you will apply this operation, even you can notice minus 3 minus m, this is coming out to your minus 3m. 1, you are multiplying it by 3m and you are subtracting it, so it will be 1 minus 3m. Either you can apply your formula or you can do like this. So this will be 0. S2, this will be 0 minus of minus m. That will be plus m. This is 0. M minus m will be 0. This is 0. Minus 3m. Here I will have minus 3m. ठीक है. आइदर यहाँ वाली एंट्री कैसे निकालोगे? 0 इंटू 2 प्लस माइनस m इंटू 3 प्लस 0 इंटू 4 यू विल गेट minus 3m. Is it clear? Yes or no? Now your m is very large, okay? And your problem is of maximization. So you can stop only when your Zj minus Cj are greater than equal to 0. So if I take m as 1000 value, right? This is minus 1003. This is minus 2999. This is minus 3000 plus 1. And this is positive. That means आपकी Zj minus Cj की एंट्री क्या है? नेगेटिव है, right? You cannot stop here. We will perform that iteration. Which variable will enter? It is my maximization case. So my most negative variable, that is my x2 variable. Is it clear? सिर्फ आपका यहाँ पे टेबल में only your Zj minus Cj will change. Rest the operations will as it is as in your simplex method. So when it will enter, we have to decide that which variable will leave. So for finding the variable to be leave, I will find the minimum ratio. That is nothing but I'll divide xb by my entering column, or I can say alpha j, and your alpha j should be greater than 0. 2 divided by 1, that is my 2. 3 divided by 3, that is my 1. And 4 divided by 1, that is my 4. Now which is minimum? 1. That means this is my leaving variable. Is it clear? Yes or no? So if this is the leaving variable, what is the intersection? This 3. So this is my pivot element. I have to make this element as 1. This element 0, this element 0, and this element as 0. Apply your row transformation and then get the new table. So now your basic variable will be S1 will be on its place. On the place of A2, X2 will come, and on the place of S3 will come. The cost coefficient here, it is 0, and A2, X2 cost coefficient is -1, and S3 cost coefficient is 0. In some of the books, they don't write these entries. That is your CB. That is even not necessary. आप चाहे लिखो चाहे नहीं, because this you are getting only when you are solving this, right? So we have to make this element as 1. How can I make this element as 1? I have to divide second row by 3. So it will be my 1 by 3. It is 1. It is 0. It is -1 by 3. And it is 0. The main basic is, once your artificial variable leave the basis, you will never let it enter again. तो आप चाहे इसकी एंट्रीज लिखो चाहे नहीं, it does not affect your table. Am I clear? That once your artificial variable will leave the basis, either you write it entry or not, because artificial variable के लिए आपको penalty pay करनी पड़ रही है, ठीक है? आप दोबारा आप उसको एंटर करवाओगे ही नहीं, क्योंकि उसके लिए आपको पेनल्टी पे करनी पड़ रही है. So whether you write its entry or not, that is your wish. So here it will be 1. I have to make this element 0, so I can apply the operation on R1. That R1 will be R1 minus 1 into your new R2. So that is your 5 by 3, 0, 1, 1 by 3. And this is 0, and this entry is coming out to be your 1, and you have to make this element also as 0, so you will apply the operation on R3. That R3 will be R3 minus 1 times your new R2, right? So this entry is already 1, 0, so when you will subtract, this is -1 by 3, this is -1, 0, 1 by 3, and this is 1. And here you will get answer as 3. You have to make this element as 0. 0 banana, but kiski help se? With the help of 1. So you will apply operation on R0. That R0 will be R0 minus 1 minus 3m into your new R2. Is it clear? So only for this calculation I was telling you that you can take m as very large value अगर आपको calculation difficult लग रही है. Is it clear? So when you will write it, this किसमें? I am multiplying the same element with this and subtracting it so that it becomes 0. Sorry, it is 0 actually. So this entry is becoming, this is my Zj minus Cj. And now these entries are my minus 10 by 3. And this is your 0, 0, 1 by 3. And this is 0 and -1. So you can even notice Here your S1 is basic variable, so you have 1, 0, 0. You have X2 basic variable 0, 1, 0. You have S3 variable 0, 1, 0. And S1 corresponding to this X2, this is 0. S1 corresponding to this is your 0, right? Can you stop at this iteration? No, because my all Zj minus Cj are not greater than equal to 0. If it is not greater than 0, that means this is my entering variable. I have to decide my next leaving variable so I can continue. So is this since this is my leaving entering variable, so 1 divided by 5 by 3, that is your 3 by 5. 1 divided by 1 by 3, that is your 3. And this you will not divide by because here your entry is less than 0. Is it clear? So what is your leaving variable? Your S1 is my leaving variable and this is my pivot element. I have to make this element as 1, this as 0, this as 0 and this element also as 0. So when you will update its basis, it will be x1, x2, s3. x1's cost coefficient is 3, minus 1, 0. How you will make this entry as 1? That you will R1. You divided it by 5 by 3 or you can say I can multiply it by 3 by 5. Both are the same things. Is it clear? So when you are writing this step, so it will become 1, 0, 3 by 5 and 1 by 5. This is your 0. Here your entry is 3 by 5. And this element you have to make 0. So you can apply your row transformation that R2 minus 1 by 3 into your new R1. So this entry will become 0, 1, minus 1 by 5, minus 2 by 5. And this is your 0. This entry is 4 by 5. I have to make this element as 0. So I can apply the operation on R3. That R3 will be my R3 plus 1 by 3 times my new R1. So this entry will become 0, 0, 1 by 5, 2 by 5, 1, 16 by 5. You have to make this entry as 0. So we have to apply the operation on R0. That R0 will be R0 plus 10 by 3 into my new R1. So this entry Zj minus Cj. This will become 0, 0, 2, 1, 0. And here you got answer as 1. Now can I stop at this iteration? Yes, because since all Zj are minus Cj, all are my non-negative, right? So I can stop here. So what is my optimal solution? That x1 is my 3 by 5 and x2 is my 4 by 5. स्लैक और सरप्लस वेरिएबल आप चाहे लिखो चाहे नहीं, बट अगर आपके एक्साइज हैं कुछ, अगर x3 होता देन यू गिव वैल्यू कि x3 मेरा 0 है, राइट? सो दिस इज माय ऑप्टिमल सॉल्यूशन and this the optimal value is that is my 1. Is it clear? Fine. So we will do it one more example. So the next example is that you have to maximize z, that is 2x1 plus 3x2 plus 4x3 subject to you have constraints 3x1 plus x2 plus 4x3 less than equal to 600, 2x1 plus 4x2 plus 2x3 greater than equal to 480 and 2x1 plus 3x2 plus 3x3 is equal to 540. and x1, x2, x3 all are greater than equal to 0. So since it is not mentioned even in this case, you cannot apply your simplex method. Why? Because you have inequality greater and equal, so you cannot apply. So when you have to apply your big M method, so you have to convert your LPP into its standard form. So that will be your this thing plus S1, that is equal to your 600. This is 2x1 plus 4x2 plus 2x3 minus S2. This is equal to 480. And this is my 2x1 plus 3x2 plus 3x3 equal to 540. And your x1, x2, x3 all are greater than equal to 0. You have added two slack variable that will be greater than equal to 0. Here it will be 2x1, 3x2 plus 4x3, 0 into S1, 0 into S2, right? Now if I have to start my big M method, what I have to do, where I have added surplus variable, that means subtracted, I have to add your artificial variable. Since I am adding it in the second constraint, so I am giving name A2, right? And here is also your equality constraint. So you have to add your A artificial variable, and A2 and A3 will be greater than equal to 0. Now your case is of maximization. So it will be minus M A1 minus M A2 minus M A3. Is it clear? I have added two artificial variables, so I have subtracted minus M into A2 minus M into A3. Now you can start your iteration. So here you all write your Zj minus Cj, and obviously your basic variable in this case, that will be your S1 from the first, A2 from the second, and A3 from the third. Here you have entries x1, x2, x3, S1, S2, A1, A2. Sometimes we write here solution, some books write XB. So here entries will come as it is 3, 2, 2. X2 column it is 1, 4, 3, and X3 column it is 4, 2, 3. This is 1, 0, 0, 0, minus 1, 0, and here it is 0, 1, 0, and this is 0, 0, 1. So when you write, if you negate it, it's the sign. This will be minus 2. This is minus 3, minus 4, 0, 0, M and M. So that what I have told you. Either you can use the formula Z1 minus C1, that is your CB into alpha J minus C1. So CB means the cost coefficient. Cost coefficient आपके क्या है इसमें? Here it is your 0. This is your 0. This is your minus M and minus M. So this you can write here 0 minus M minus M. Alpha J, that is your first at this is table 322 minus C1. C1's cost coefficient is 2. When you will do this, this is minus 4M minus 2. So either you can apply formula or you can use your row operation. Row operation कैसे use करोगे? R naught. You have to make this M as 0 and this M as 0 with the help of this one and this one. You can joint operation you can apply. That R naught is my nothing. That R naught is my minus M times my R2 minus M times my R3, right? Or you can apply it 1, 1, right? Because you have to make this M as 0. With the help of this one, you have to make this m as 0 with the help of this one. So if you will apply the operation, even then you will get same answer. So this is given by minus 3 minus 7m, minus 4 minus 5m, 0, m, 0, 0, and here it was entry as 0. When you will apply the operation, you will get minus 1020m. And here entry, obviously your right hand side, this is your 600, 480 and 540. This entry you can also get that you will multiply this with this plus this into this plus this into this. You will get this entry. Is it clear? So now it is of case of maximization. Can I stop at this iteration? Your m is very large. If you give value here, it is minus 7003. It is minus 4002. It is minus 5004. What is your most negative? If you have confusion with m, you can use your m as very large value. So what is your most negative? x2. That means my x2 will enter and who will leave the basis I have to decide with. Minimum ratio, that I'll divide 600 by 1, 480 by 4, and this is 540 by 3. So this is coming out to be your 180 and this is 120. So which is minimum? 120. That means this is my leaving variable. So this is my pivot element. I have to make my pivot element as 1. This element 0, this element 0 and this element 0. So when you will perform next iteration, your S1 will be on its place. On the place of A2, what will come? X2 will come, and on place of A3 will come, and the cost coefficient corresponding to S1 is 0. X2 cost coefficient is 3 and A3 cost coefficient is your minus m. You have to make this element as 1. So which operation you will apply? R2 by 4. Right? So when you will perform this operation, it will become 1 by 2, 1. This is 1 by 2, 0, minus 1 by 4. This will become, since my A2 has left my basis, it is not A1, it is A2 and A3. And since my A2 has left the basis, so either I write its entry or not, it does not affect me. I have to write only the next entry. So that is coming out to be your 0. And this entry is your 120. You have to make this element 0. So you will apply the operation on R1. R1 minus 1 into your new R2. So the entries will be 5 by 2, 0, 7 by 2, 1. This will be my 1 by 4. And here entry 0. This will be my 480. And I have to make this element 0. So I'll apply operation on R3. R3 minus 3 into my new R2. So that the operation will become, this is 1 by 3 and 0, 3 by 2, 0, 3 by 4, and this is 1, 180. And you have to make this entry also as 0. So you will apply operation on R0. R0 plus 3 plus 7m into your new R2. Chahe minus, you can multiply and then you can subtract, you will get this operation. So this entry will become minus half minus m by 2. And this is 0 minus 5 by 2 minus 3m by 2. This is 0 minus 3 by 4 minus 3m by 2, 4, sorry. And this is your entry 0. This is 360 minus 180m. Even you can verify 0 multiplied by 480, 0. 3 multiplied by 120, that is your 360, minus m into 180, that is your 360 minus 80m. Is it clear? Now, can I stop at this iteration? No. So, we have to decide most negative. So, in this case, your most negative is becoming this entry, because here you are dividing it by 4 and here you are multiplying by 3 but dividing it by 2. Either you can give m as very large value and you can solve the question. So, since this is my entering variable, I have to decide my leaving. So, this is 480 divided by 7 by 2. That is your 960 by 2. And this is your 120 divided by half. So, that is your 240. This is 180 divided by 3 by 2. That is your 120. So, which is minimum? 120 is minimum. 960 by 7. So, still it is your minimum, right? So, this is your pivot element. We have to make pivot element 1, this element 0, this element 0, and this element as 0. Apply the operation. So when I'll apply the operation, S1 will be on its place, X2 will be on its place. On the place of A3, what will come? My X3 will come. I have to make this element as 1. So I'll apply operation R2 into 2 by 3. So that will become, this is my 1 by 3. This is your 0, 1. This is 0. And this entry is 1 by 2. This you can leave now. This you can leave. And this entry is becoming 120. I have to make this element as 0. So I can apply on operation on R2. That will be R2 minus half times mu R3. So that operation will become, this is your 1 by 3, 1, 0, 0, minus half. This is my 60. Next, the operation on R1. R1 will be R1 minus 7 by 2 times my mu R3. And this operation will become 4 by 3, 0, 0, 1, minus 3 by 2. This entry is my 60. And I have to apply this as 0. So I can apply the operation on R0. R0 plus 5 by 2 plus 3m by 2 into your mu R3. So this entries will become 1 by 3, 0, 0, 0. And this is minus, sorry, this is half. And this is your 660. So my objective was to maximize my all Zj minus Cj are greater than equal to 0. That means I can stop at this iteration. So what is my optimal answer? Here your entries, this you can write, this is your 0. X2 is your 3, this is your X3, this is 4. So your optimal answer is X1 you have not obtained, that is your 0. X2 is 60 and X3 is your 120. This is the optimal solution. And the optimal value, that is my 660. Is it clear? The last tip in this table, suppose I give you the last table, that is I have given you the last table only, right? And I am asking, you have not written the entries of your A2 variable, right? So if I ask what is the column of A2, so how you can tell? I have not performed any operation, but I am asking it what is the column of A2. Can you tell? If you notice the tip in this, जो आपका S2 वेरिएबल है, so if you have like this, जो A2 का बिहेवियर है that is just the opposite of S2. तो जो भी आपका S2 का कॉलम होगा and A2 column just it will be the opposite, negate of this. This is the column of your S2. So A2 column अगर आप परफॉर्म करते भी तो यही आता 3/2, 1/2 and your -1/2. This is the column of your A2. Okay, thank you.